Hi, welcome to another video. So Anthropic has launched Claude Opus 4.8, and this is one of those releases where, at first glance, it looks like a small update, but after testing it, I actually think it is a pretty important one. It is not a completely new generation or anything crazy like that. It is still an Opus model, it is still priced like Opus, and Anthropic themselves are basically saying that this is a modest but tangible improvement over Opus 4.7. But the interesting thing is that, in my own testing, this was not modest at all. This is the first model to score 87% in my benchmark, and that is kind of wild, because I have tested a lot of models with the same set of questions. I tested DeepSeek, GPT 5.5, Opus 4.7, Gemini 3.5 Flash, Mimo V2.5 Pro, and now Opus 4.8. And Opus 4.8 scored 61 out of 70, which is 87.14%. So let's get right into it. First, let's talk about what Anthropic is claiming with this model. They say Opus 4.8 builds on Opus 4.7 with better benchmark performance, better collaboration, and better agentic work. It is available today at the same regular pricing as Opus 4.7, which is $5 per million input tokens and $25 per million output tokens. So the base price did not go up, which is great. They also now have fast mode for Opus 4.8. According to Anthropic, fast mode can run at around 2.5x the speed, and the fast mode pricing is now 3 times cheaper than it was for previous models. Fast mode is still more expensive than the regular mode, but this is good because at least the expensive fast option is becoming more reasonable. The other big thing is effort control. Opus 4.8 defaults to high effort, and Anthropic says this gives the best balance of quality and user experience. On coding tasks, high effort uses a similar number of tokens to the Opus 4.7 default, but it performs better. You can also choose Extra, which is called X-High in Claude Code, or Max, where it will spend more tokens to get better results. So, basically they started with the old reasoning token style, where you had to think about max tokens and budget tokens and all that stuff. And now they have made it more like what OpenAI does with reasoning effort. You just pick the effort level and let the model decide how much thinking it needs. I think this is a better approach for normal users. Most people do not want to sit there and think, okay, should I give this 16,000 thinking tokens or 32,000 thinking tokens? They just want low, medium, high, X, high, max, and that's it. Anthropic also says Opus 4.8 is especially strong at long horizon work. In Claude Code, they are launching something called dynamic workflows, which is in research preview. The idea is that Claude can plan a big task, run many parallel subagents, verify the output, and then report back. This is meant for very large tasks like code-based scale migrations across hundreds of thousands of lines of code. So if you are doing a huge refactor or a migration, that is where this model is supposed to shine. They also added support for system messages inside the messages array in the API. This is actually pretty useful for agent developers because now you can update Claude's instructions in the middle of a task without ruining prompt caching or pretending it came from a user message. You can update permissions, token budgets, environment context, and stuff like that while the agent is running. Another thing Anthropic is highlighting is honesty. They say Opus 4.8 is around 4 times less likely than Opus 4.7 to let flaws in its own code pass unmentioned. And honestly, that is something I care about a lot more than a random benchmark number. Because one of the most annoying things with coding models is when they confidently say everything is done, but the app is broken, the tests do not run, or the UI is completely different from what you asked for. A model that says, hey, this part might still be wrong, or I'm not fully confident about this, is much more useful than a model that just says done every time. Now, the prompting guide for Opus 4.8 is also interesting. Anthropic says that Opus 4.8 is more literal with instructions, especially at lower effort levels. So, if you want something to apply to every section or every file or every test, you should say that clearly. Do not assume it will generalize your instruction. They also say effort matters more for Opus 4.8 than for previous Opus models. If you're getting shallow reasoning on a complex task, the better fix is not necessarily to write a longer prompt. The better fix might just be to raise the effort level to high or X-high. For frontend, they say Opus 4.8 has strong design instincts, but it can have a kind of default house style, warm off-white backgrounds, serif display fonts, terracotta, or amber accents, that kind of thing. So if you are building dashboards, dev tools, finance apps, or anything enterprise-looking, you should specify the visual direction more clearly. This is pretty funny because a lot of these models develop their own default taste. Sometimes it is purple gradients, sometimes it is glass cards, and now apparently Claude likes the editorial coffee shop aesthetic, which can look good. But if you ask for a serious dev tool, you probably do not want your app to look like a boutique bakery. Anyway, that's the official side. Now let's talk about my testing, because this is where it gets really interesting. I used my normal benchmark, where I give models 7 tasks. These are not perfect scientific tests, obviously, but they are very practical. They include front-end tasks, 3D tasks, an SVG task, a small game, a math problem, and a local fine-tuning style task. And the reason I like this benchmark is that it does not only test whether the model can write code, it tests whether it can understand weird instructions, whether it can build something visual, whether it follows constraints, whether it can reason, and whether it can produce something that actually works in one shot. The first question was an elevator simulation. I asked it to make an elevator simulation where the user can spawn people on different levels. Each elevator can only take one person. There are 3 elevators. People should have random target floors, and the model had to show a small tooltip with the floor number when hovering over people. It had to be well-animated, good-looking, simple, and all in one HTML, CSS, and JavaScript file. This is a surprisingly hard task because it sounds simple, but there are a lot of moving parts. You need people, floors, elevators, capacity constraints, delayed pickup behavior, target floors, animation, and the tooltip. Most models either make it look okay but ignore the capacity rule, or they follow the rule but make a really ugly static thing. Opus 4.8 got 10 out of 10 here, and this was a really good start. It understood that each elevator should only take one person, it left other people behind, and then the next elevator could pick them up. The animation was good, the UI was simple, and the tooltip was there. So this was a clean pass for comparison. Opus 4.7 also got 10 on this one. GPT 5.5 got 5, Gemini got 6, DeepSeek got 3, and Mimo got 5. So Opus was already strong here, but 4.8 kept that strength. The second question was a three.js contact lens case. I asked for a 3D model with pronounced L and R places with caps, and I wanted to be able to click the caps and open them. This is the kind of task where models can fake it very easily. They can make a rectangle, put L and R text on it, and call it done. But the actual requirement is that it should feel like a 3D object, and the caps should be interactive. Opus 4.8 got 7 out of 10, so not perfect, but pretty good. The model did make the contact lens case recognizable, the L and R labels were visible, and the cap interaction worked. But it was not the most polished 3D object in the world. There was still some room for improvement in the modeling and the physical feel of the caps. Still, compared to the other models, this is quite strong. DeepSeek got 3, GPT 5.5 got 5, Opus 4.7 got 5, Gemini got 0, and Mimo got 1. So Opus 4.8 was clearly better here. The third question was a three.js folding table with a slider. When the slider goes to the right, the table should unfold, and when it goes left, it should fold. It should be seamless, animated, and 3D. This is another very good test because it checks whether the model understands motion and mechanical relationships. It is not enough to just rotate one cube. You need the tabletop and legs to move in a way that feels connected. Opus 4.8 got 8 out of 10. It made a pretty decent 3D folding table. The slider worked, and the animation was much better than what most models produced. It was still not absolutely perfect mechanically, but it was good enough that you could understand the folding behavior immediately. DeepSeek got 5 here, GPT 5.5 got 3, Opus 4.7 got 5, Gemini got 3, and Mimo got 1. So again, Opus 4.8 was ahead. The fourth question was much simpler on paper. I asked it to make an SVG of a panda eating a burger. Now, this is not a coding agent task exactly. This is more of a visual creativity and instruction following task. Some models make a panda, some make a burger, but a lot of them fail at actually making the panda eat the burger in a readable way. Opus 4.8 got 6 out of 10. This was one of the weaker results from Opus 4.8. It was okay, but not amazing. It created the general idea, but the composition was not as strong as I wanted. Gemini actually did better here with 8 out of 10, and Opus 4.7 got 7, GPT 5.5 got 5, DeepSeek got 3, and Mimo got 5. So, this is one place where Opus 4.8 did not dominate. It was fine, but I would not call it the best SVG model from this test. The fifth question was a bow and arrow simulator game. I asked for 4 targets, and hitting the target in the lowest time should make the player climb the leaderboard. This is a very practical game-building test. You need aiming, shooting, target collision, timing, and a leaderboard. If the model forgets any one of those, the game becomes incomplete. Opus 4.8 got 10 out of 10. This was one of the best outputs in the whole benchmark. The game worked, the targets were there, the timing logic made sense, and the leaderboard actually reflected better times. It was not just a visual toy, it was a real playable minigame. Opus 4.7 also got 10 here, GPT 5.5 got 6, Gemini got 5, DeepSeek got 5, and Mimo got 2. So, again, Opus models are very strong at these interactive one-file tasks, and 4.8 kept that pattern. The sixth question was the math problem. This one asks for the number of permutations of ordered pairs of non-negative integers, where x goes from 0 to 19 and y goes from 0 to 2, with specific movement rules. The correct answer is 2460. This is the type of question where most models just completely fail. They either misunderstand the grid, they count paths incorrectly, or they produce a confident wrong answer. Opus 4.8 got it correct. It gave 2460, so it got 10 out of 10. Every other model in this table got 0 on this question, except there were no partial wins here. DeepSeek got 0, GPT 5.5 got 0, Opus 4.7 got 0, Gemini got 0, and Mimo got 0. So this is a huge deal. This single question is one of the reasons the final score looks so strong. It shows that Opus 4.8 is not just making pretty frontends. It can also solve a pretty annoying combinatoric style problem that other models missed. The seventh question was probably the most unrealistic one, but that is the point. I asked it to generate a dataset of facts about pandas, then fine-tune a Gemma 2B model on that dataset and give me a local web UI where every refresh generates a panda fact. I also said I do not have anything, do it all on your own, and it should all be local. Now obviously, actually fine-tuning a model locally depends on hardware, libraries, download sizes, and a lot of setup. So this test checks whether the model can give a complete local workflow and build the surrounding app properly without pretending that everything magically happened. Opus 4.8 got 10 out of 10. This was impressive because it handled the task as a full local project. It generated the dataset approach, gave the training flow, and created a web UI concept that made sense. It did not just give a fake panda facts page and ignore the fine-tuning part. The other models did really badly here. DeepSeek got 2, GPT 5.5 got 3, Opus 4.7 got 2, Gemini got 2, and Mimo got 0. So this was another big win for Opus 4.8. Now, if we look at the final chart, this is where the gap becomes very obvious. DeepSeek V4 Pro got 21 out of 70, which is 30%. GPT 5.5 got 27 out of 70, which is 38.57%. Opus 4.7 got 39 out of 70, which is 55.71%. Gemini 3.5 Flash got 24 out of 70, which is 34.29%. Mimo V2.5 Pro got 14 out of 70, which is 20%. And Opus 4.8 got 61 out of 70, which is 87.14%. So, this is not a tiny improvement in my benchmark. This is a massive jump from Opus 4.7. It went from 39 to 61, which is very impressive. Now, one thing I should mention is that I used Verdant for this testing, and honestly, Verdant is still really good for these coding model tests. The reason I like it is that it makes it very easy to run these tasks, check the output, and compare things. It also supports your Claude Code subscriptions and stuff like that, which is great because you do not always want to pay separately for every single API call if you already have access through a subscription. For the price, Verdant seems better to me than Codex in some ways, especially if your workflow is based around these coding agents and you want to test different models quickly. But the situation is still kind of weird because Claude Code rate limits can be pretty bad depending on your plan and how aggressively you use these high-effort models. So the model is really good. It is the best model I have tested so far in this benchmark. It crushed the coding tasks, it got the math problem right, and it did very well on the local fine-tuning workflow. The only task where it was not amazing was the Panda SVG, and even there it was not terrible. But I still would not say everyone should blindly switch to it for everything. If you are doing basic chat, simple coding, or small edits, you probably do not need Opus 4.8. It is expensive compared to smaller models, and high effort can burn through limits. But if you are doing long coding tasks, difficult front-end work, agentic workflows, big refactors, or anything where failure is more expensive than tokens, then this model is genuinely worth trying. And if you are using Claude Code, I would test high effort first. If the task is very difficult or long-running, then use X-High. I would not use Max all the time, because that can get expensive and slow very quickly. But for the hardest tasks, it might be worth it. Overall, Opus 4.8 is pretty amazing. I did not expect it to jump this much in my own testing, but it did. It is not perfect, and the Claude ecosystem still has some annoying limits, but as a coding and agentic model, this is probably the strongest thing available right now. So, this is great for sure. Overall, it's pretty cool. Anyway, let me know your thoughts in the comments. If you liked this video, consider donating through the Super Thanks option or becoming a member by clicking the Join button. Also, give this video a thumbs up and subscribe to my channel. I'll see you in the next one. Until then, bye.